Hi everyone, welcome back. In this tutorial, not only this one, it is actually a series of tutorials about Numpy. Throughout this series of tutorials, first of all, I will go through a quick introduction of Numpy with our learning objects of like how we can create an array, make a mesh grid, for instance. And in the second tutorial, we will learn about the index, slicing in one-dimensional, as well as multi-dimensional array. We also take a look at the Boolean index and learn the way to reshape an array. In the third tutorial, we will learn about matrix and vector operations, things like how to do the addition, subtraction, and division. We also go through some basic calculations such as averaging over different dimensions of multi-dimensional array. And finally, we will visit a single value decomposition. Together with a discussion of SVD, we also learn how to calculate the eigenvector and eigenvalue. Okay, without any further ado, we start our first tutorial today. As usual, the first thing we will do is to load the library. Here I am using Matplotlib and Numpy. I am using Matplotlib because I want to plot a figure later, just for the sake of my demonstration. For this tutorial, we are focusing more on Numpy. Okay, in the second step, we will create a vector with the name is test underscore here, and I have a number from 1 to 9 in a square bracket. So how do I know it is a list? We can check that by using the command print type test here, and it is showing us its type is a list here. Now we will put this list into array function in Numpy, which is np.array, as you can see here. After that, we can also use a similar command print type in order to check its type. And now we have an array from 1 to 9. This is one-dimensional array. And now we move to a multi-dimensional arrays. Here I have a variable named data1. Notice the location of square brackets. As you can see, when I print out this array, I have a 5x2 matrix, which is corresponding to 5 small square brackets inside another square bracket. We can also print the dimension, the shape, the size, the type of this array by using the following commands. So now we have a number of dimension is 2. The shape is 5x2, which is 5 rows and 2 columns. The size is 10, and the type is integer. Okay, now we move to another example. Here is my array data2, and it is specified like this. When we print out its properties, what is the differences compared to the one we saw earlier? We reduced the number of columns. In here, we only have 5 rows and 1 column. So I hope with this example, you understand how we can have more columns or less columns, and vice versa for the row. Now we will go to the third example, and please notice the location of the square brackets. It is basically similar to the second example, but the number is duplicated. And then when we print out this array, we will immediately see that its shape is now 2 by 5 by 1, which stands for 2 layers, 5 rows, and 1 column. Okay, we move on the next section to learn other ways to create an array in Numpy. We can also create an array by using the command numpy.orange. Inside the parentheses, we have the start as the number 0 and the end as number 10, with the incremental step is 1. So when we print, we realize that the first value is 0 and it is okay, but for the last value, it is not 10. So in Numpy, for this particular command, it is not going to the last index. It goes from the last minus 1. It goes to the last minus 1. Therefore, let's say if one wants to have an array from 1 to 10, and the final index should be 11, as you can see in this command. We can also use linspace to create an array. It will return an even space numbers over a specified interval. For instance, in this example, our interval is from 0 to 10, and 5 is the numbers that in that interval, so that we can have 4 equal spacing, as you can see here. We can also create a log space array as shown in the command y equal numpy.log space here. We have a number 0 and 2 here, which stands for the number 10 to the power of 0, which is 1, and 10 to the power of 2, which is 100. And the number 100 here is the number of points in this range. So to help you easily understand, I'm plotting the image here where the y value is in the y-axis with the range from 1 to 100. The x-axis from 0 to 99 for 100 points. Okay, we move on to the next section, which is to specify the type of an array. The main purpose of this section is just to be clear about the type of an array. For instance, whether it is integer, float, or complex. Here I have an array named test. As you can see in the first and second indices, we have float value of 1.5 and 2.5. So if we use this if we use the integer type, these two numbers will turn into 1 and 2. So as to preserve these numbers, we need to specify its type as float. We can also specify if the numbers are complex. Since the complex number has a real and an imaginary part, so we can separate them by using the commands like in here. Okay, we move on the next section where we will discuss about the mesh grid array in Numpy. So the Numpy mesh grid functions is used to create a grid out of two given one-dimensional arrays, representing a Cartesian indexing or matrix indexing. So the one-dimensional array here, for instance, x and y, we can see that each array has 7 elements. By using the mesh grid function, we can turn these 7 elements into an array 7 by 7. In this example, x is something like longitude, and y is something like latitude. And for clear illustration, we can think of an example of surface temperature, which is two-dimensional array. And then we would like to plot this temperature with a longitude and latitude, and the function mesh grid helps us to do that. So now we see the big X array has a shape of 7 by 7. Similarly, for the big Y array, suppose that our temperature is an artificial value of big X, X and Y, X plus Y. We can plot this temperature array onto the big X and Y axis. As you can see, in the y-axis, we have value from minus 90 to 90, and in the x-axis, it is from minus 180 to 180. Yeah, now we move on to our final section of this tutorial. First of all, creating a zero array. Here, I have an array of 2 by 4, 5 rows and 5 columns. By using this command, every element of an array has a value of 0. We can use this as a reinitialized array and store value from other calculations. Second, creating all-one value array, where we have all elements are equal 1. Thirdly, we can create an identity array where the diagonal line is equal 1 and elsewhere is equal to 0. Similar function can do the same thing is numpy.i, with a k equal 1. It is interesting that when we modify this k value, such as k equal 1 or minus 2, the diagonal line will move to the upper or lower triangle respectively. And if you are curious, we can create some fun magic, such as only the diagonal has a value, and its value increase, such as in here from 5 to 45 with the incremental step of 5. And we can also shift this diagonal line as in the numpy.i command too. All right, it is all done. And please feel free to let me know if you have any questions, and please subscribe my YouTube channel too. Thank you very much.